It's time to master decorators. Stick around, and by the end, you will be coding decorators like a pro. You will learn basic decorators, decorators with arguments, decorators with their own arguments, and how to stack multiple decorators. Hello coders, welcome to my channel. I'm David, your guide to mastering programming. To understand the decorators to the fullest, it's recommended to first understand closures. A closure is a function defined inside another function that remembers and can use variables from outer function scope even after the outer function has finished executing. Let me show you what I mean by that. I'll create a regular function and call it remember, and here write some parameter, for example x. And inside this function, I can create another function and name it add, and this function will have its own parameter n. Now I want this add function to add these two numbers and return them. For example, return n plus x. Now I need to return this inner function add. I'll create a variable and call it add5, and to this function remember I will pass 5. This x will have a value 5, and this inner function remembers that x has value 5 even though this add function is not executed, just this outer remember function. Also, since I return the function add, now this add5 is a function, so I can call something, I can pass something to this add5, which in this case will pass something to this inner add function. So I can here write add 5 and pass 3. Now I expect to see 8. Also, I will show you that this add 5 is indeed a function. As you can see, add 5 type is function and 8 is printed because 5 plus 3 is 8. If you found this video helpful, make sure to hit that subscribe button. It really helps me out. Thanks for your support. Now you have learned everything you need to know before starting to learn decorators. First, I will show you why you need to learn decorators and why they're useful. For example, if I have many functions that print something, I'll call mine printer, and this function will simply print hello. So, so now when I call this function printer, I expect to see hello, and I will see hello. But maybe I changed my mind and I want, before I print hello, I want to print, for example, something before it. Then in that case, I would need to print here print, and here print again, and inside this print something. But what if I want to change that for every function that prints something? That's problematic because in that case, I need to copy this line of code several dozens of times, or hundreds of times, or thousands of times. So this is not very efficient. That's why decorators were invented. Decorator adds or modifies behavior of a function without changing its code. Let me show you how to create a decorator. Decorators are created like regular functions. You need to write the keyword def, and here write the name of your decorator. For example, I will call my decorator just decorator. But this decorator has to have one parameter. It can have many parameters, but the first parameter has to be a function that I will pass to this decorator. For example, this printer function. The convention is to call that function func so that it reminds you that this parameter is a function. Also, now inside this decorator, I need to write the inner function. The convention of the name of the inner function is to call it wrapper. Wrapper can have arguments if your function has arguments, but mine doesn't, so I will leave these arguments as empty. Now I will print, for example, before, and now I will call my function, and then I will print after. Also, it's important to return your decorator and your inner function, and I will show you why. You don't need to write these parentheses, but it won't hurt your code. To call your decorator, you need to write at the rate sign and then the name of your decorator. This will automatically pass this printer function as the parameter to this decorator. So this func parameter will be equal to this printer function. So now when I call this printer function, I expect to see before, then execute my function, which will print hello, and then print after. As you can see, before, hello, and then after. This piece of code is the same as this line of code. Printer equals decorator, and then you pass to this decorator your function printer. I hope this now makes a little bit more sense. This printer will become equal to what this decorator returns, and this printer will be passed as a parameter to this decorator. So now this function becomes this printer, and this wrapper is a new function that will edit how this printer looks. As you can see, it prints this, then you execute your function, then print, and you return this wrapper. So now this printer becomes this new variation of this printer function, which is this wrapper. As you can see, this didn't change how this printer works. It just modified it. It adds some behavior, this print. Also, the function that you want to decorate can have some arguments. For example, here print, I don't know, X, and here, oh no, for example, name, and here hello name, but this has to be f string. In which case, this wrapper function has to have some parameters as well. It's common that you write here infinity positional arguments and infinity keyword arguments. The syntax, I mean, the convention is to call these args as arguments and these quarks as keyword arguments. Why you need to write this? Because you don't know how many parameters your functions will have. For example, this one has one, but maybe some other will have two or three, and maybe they will be passed as keyword arguments. Here, they're not. In that case, you need to write this, and now you will get all the arguments, no matter how many they are or how they are passed. But in that case, you need to pass them to your function. For example, here you need to pass args and quarks. Here I will print all the arguments that exist. For example, f string, and here arguments, no, args equal to args, and here quarks equal to quarks. Now when I run this code, oh, I didn't pass anything to my printer function. I'll pass some name, for example, David. Now when I run this code, as you can see, it says args David, quarks empty, and hello David. This David is passed, as you can see, as a positional argument. So these star args will get this David. And because there is no positional arguments, I mean keyword arguments, these quarks will be empty, as you can see here. But if I wrote, for example, here name and then equal David, now these args will be empty, but these quarks will have name David. We'll get the name David. As you can see, now args is empty, but quarks has name and David. Decorators can have their own arguments. For example, if I want my printer function to print me this name multiple times, like three, four, or I don't know how many, I need to write something like this. I can't simply write here comma and then write the parameter. I need to wrap this decorator in another function. So I will call this function first. I will cut this, and here I will call this function repeat, and here number. This is that parameter that I want to pass, how many times I want to repeat this printer function. And here I will pass my regular decorator from before. But now I need to return this decorator as well. Return decorator. As you can see, this decorator is now outlined with this red line, which that's because now this decorator is no longer the decorator that I create. Now this repeat is regarded as a decorator. So here I need to write repeat, but I need to pass this number. How you pass something to a function? You need to open the parentheses and write here, for example, 3. I will comment this, and here I will write for I in range num, call my function that many times. Now I will leave this so you can see how this works with arguments. Now when I run this code, I expect to see this. First, this line is printed. Since I passed this name as a keyword arguments, this args is empty, but this quarks gets what I passed. And this for loop repeats my printer function 3 times. If this confuses you, I will show you how this looks alternatively. When Python sees this repeat 3, this code looks like this under the hood. Decorator is equal to repeat 3. Now this decorator is the regular decorator from before. So now next code is completely the same. This printer function is equal to decorator, and now I need to pass this printer. That's how decorators with their own arguments work. This outer function just is used just to get this parameter, and this decorator now becomes the regular decorator from before when this repeat is executed, and this printer function becomes the decorator, I mean the wrapper function from the decorator. Cool thing with decorators is that you can stack them, but maybe you wonder how they are executed. Let me show you. For example, I create a decorator deck print that will decorate how I print. One, no, I will call it deck one. Get it will get the function, and then def wrapper. For the simplicity, I won't write here any arguments. It will be a simple decorator that prints something. I mean, the simple function that will print something. And here I will write print deck one start, and here execute the function, and then print deck to end. I will copy this, call deck 2. Whoa, I forgot to return wrapper. Here, return wrapper. I will create another function, def printer, and this function will simply print hello. First, I will call my deck 1, then I will call my deck 2 decorator. So now when I call my printer, what do you expect to see? Write down in the comments below if you know. As you can see, the deck 1 start is written first, then the deck 2 start is written, then my function is executed, then my deck 2 end is written, and then my deck 1 end is written. So stacking decorator works like this. The first one that you write wraps everything that comes after. So when you write next deck 2, now this wraps this printer, but this deck 1 wraps both of them. So that's why this deck 1 starts first, but it's printed last here. This deck 2 is started second, but ends first because it's closest to this printer function. Also, now I remembered something I didn't tell you. If you want your function to return something, then your wrapper needs to return something as well. For example, if my function would return here, return hello, then if you want to decorate this function, but you want this function to still return something, then your wrapper function needs to return the function. For example, here, return func. Now, this will return this hello. But as you can see, this is yellow. Why? Because when you return something, this will never be executed. In which case, you need to write a variable, for example, result, to be equal to this function. Now these two will be printed, and at the end, you can return the result. I hope you found this video helpful. Like and subscribe for more coding content. See you in my next video. Until then, keep coding.